Hello again. The last section in chapter 10 is 10.8. It's application of power series. And we say that before as the useful for finding what? For finding the solution or approximation solution, you can use one of them. So we have a series. Here's the formula of the series. You can find it later. I'm going to give you. We need the function itself, derivative, second derivative, third derivative, and go. So here is the application. So we need many things to recall. For example, you can see we have two names, Tyler and Maclaurin. They are the teachers and the student. So both of them, they have the formula. Tyler make a formula, Maclaurin get a special case. So we have what? We have a Tyler in general at x equal to a, and also we have a Maclaurin at x equal to 0, like a previous formula. For power series, we have two formula, for 0 and a. Now again, we have the same. What's different between here and the other side? Here we have, for example, we say f of x, the Tyler of f of x, or you can say is the formula is equal from x minus a over k factorial, k and k, or in such book from 0 to infinity. In such book maybe written by n. We write x k to distinguish between the Tyler and the others. Otherwise, they are the same. So what's f of k? F of x k, what's that mean? What do you mean when you write f of k? Hello? How about that one? They are equal or not? Not equal? So tell me about the left side is what? The left, when you have a power with the parenthesis, means that derivative. And instead of say function, you say just when it's 0, we have just the function. We don't say is equal to 1. When we have f prime, it's okay, we know. Or maybe you have f double prime. How about the 10th derivative? You don't write 1, 2, 3, 4, 5, 6, right? So you just write f10. And we know by this 10, you mean by the derivative. For example, what's the difference between 2 and 2? That one is the square of function, means that f circle f. Okay? But that one means what? Second derivative. You got it now, right? So in the Taylor formula, we have what? We have f of at x, k. K start from 0 to infinity. So it means that I need the first derivative function itself, first derivative, second derivative, and go on, right? So also we have what? K factorial, you know about factorial. So 0 factorial is equal to 1, 1 factorial, 2 factorial, and go on. As well, we have x minus a. A is the given. Okay, in the question will give you at say, for example, x about 2 and k. So that one is power, right? So if you expand this formula, you get what? If I put 0, I will get f of x, right? At a, sorry. And x minus what? All right, x minus a to power 0 over 0 factorial. I know 0 factorial is equal to 1. X minus a to power 0 is equal to 1 again. So this is the first formula when k is 0. Understood? Now, plus, give me the second formula. I'll get what? The second term. Yalla? K is 1. So I have f prime of a. Why? And that one will be 1. X minus a. And that one will be 1 factorial. 1 factorial equal to 1. We see that, right? Okay, give me the third formula when k is equal to 2. So you will get what? Second derivative. X minus a square over 2 factorial, and go on. So the third at a, x minus a cube, 3 factorial, and go on. So that one will be what? That one will, now you understand why f of a prime x double till n, right? Do you have any question? How about the Maclaurin formula? The Maclaurin the same. Before we have, instead of a, we have what? Sorry, k. Instead of a, we have a 0. And here we are, instead of x minus a to power k, k is equal to 0. So it remains what? The remainder will be x to power k over k factorial. When we expand that one, okay, from 0 to infinity, I'll get itself first derivative, second derivative, third derivative, and go on. You can see, you compare between the Maclaurin and during the exam. For example, I say find the Taylor series for that one. Okay, when you say Taylor, you have a. When you say Maclaurin, you have nothing. Clear? Good. Now, how's the question during the exam, your exercise, quiz? So you say find the Taylor series. So you have a Taylor series. For what? I'll give you the function. Which function? F of x is equal to 1 over x. At which? At 2. A equal to 2. So, and you can see it's like a, we have x. We have, so it means that the power series, right? So it's a type of power series. Good. Now, my function, 1 over x, my a is 2. Now it's time to apply your rule, your formula. So how we do it? Yalla. We need a formula. So it's Taylor series. So I'm going to write the formula. I say every time write this formula for yourself to deal with the situation. A x minus a k, k factorial, k from 0 to infinity. And before you expand anything, you know, during the expansion, we need such function, derivative, second derivative, third derivative. So we are going to, with a deal, at the beginning, we are going to deal with the f. We find f, f prime, f double prime, then we substitute value, then we are going to use to expand the formula. So, Kata, first of all, before doing anything, I need what? Derivative and itself. So, look at here. I say f of x equal to 1 over x. Then f of 2 equal to what? 1 over 2. First derivative equal to what? Am I right? We'll bring it to up. Derivative cheated, a beta minus 1. So, what's equal to? Am I right? Good. So, each time you need to substitute. So I'll get what? F of prime 2, 1 over 2 power 2. Understood? How about that second derivative? 2 over x to the power 3. Am I right? No? Why? Derivative of here will be minus 2, sorry, minus 2, x to the power minus 3. So it's good. So equal to what? 2 over 2 to the power 3. Kindly, do not substitute the power. Do not make a cancellation. Okay? Do not do anything. Understood? Just put it. Why? Because during the formula, we need it. You have a problem? Good. Do not do, for example, do not say that one, okay? Do not do it. Just be patient till the end. So I'm going to remove it as I have. How about the second? Sorry, the third. Minus 6 x to power 4. So I will get what? Minus 6 to power 4. So we got something. Now, 3, 4 depends maybe. 3, 4, 5, it's enough for you to get the formula. Okay. So I say now after finishing, I say fk a x minus a k over k factorial. Am I right? K start from 0 to infinity equal to what? The expansion, yalla, f of 2, f prime of 2, eh, plus f double prime of 2 plus understood. Okay. Let me substitute. F of 2 is equal to what? I don't know. F of 2 equal to what? So go put every value of here. Okay, 1 over 2 plus f prime is equal to what? Look at here. Minus 1 over 2 square. Fermo. Minus 1 over 2 square. Eh? So I have what also? X minus 2 plus. Now, I have this formula, right? So how about f double prime? I'm going to up f double prime 2, 2, 3, right? 2 over 2 to power 3. Or I'm going to make each one its color to understand, to be clear with you. Later, you will see what's going on. So plus, I have x minus 2, 3 factorial. Am I right? So let me find, yes, minus 6 over 2 to power 4. Minus 6 over 2 to power 4. And go on. It's time to do your factoring everything. Now it's time for that one. So 1 over 2, 1 over 2. Minus. Am I right? Well, so 2 factorial with 2, it remains what? Plus x minus 2 square. 2 to power 3 minus 2 to power 4 x minus 2, 3. Why? Because I know 3 factorial is equal to 3, 2, right? 6, 6, and it remains only minus. You go to Jama'at, so that 6 with that 3 cancel, it 2 to power 4. So now, and طبعا, and go on. Now I have a formula. This one is very important. I have another formula. We function to the formula. So I'll get what? Tell me. Thank you. We have, first of all, we have minus plus, right? So for example, if k start from 1, I have minus plus, right? Look, I have plus, minus, positive, negative, and alternative. So how I get the alternate? By minus 1, right? So it will be what? Minus 1 what? k plus 1. Why? Because the first is positive, right? So if k is 1, I'll get what? Negative. So to make it positive, add 1. So you'll get it. Understood? Any question? So to get negative, positive, negative, positive, I have minus 1. So if I put k to be here, I'm going to change that on k plus 1. If k is 0, I say what? Only k, right? To get positive. Understood? Hello? Good. So this is the first. Now let k be 1, and that one be k plus 1. Okay. So in denominator, I have what? We have what? Huh? 2. Okay, first is 2 to power 1, 2 to power 2, 2 to power 3, 4, right? So if I put k1, I say what? 2 to power k. Or you can change that on to n. Let me change it to n. I'm going to change that on to n. Together, do not mix it with the k. So n plus 1, right? Understood, Jamaat? So 2 to power 1, yes, you are right. 2 to power n to power 2, yes, yes, yes. Okay. How about in the numerator, I have what? X minus 2. So the power, here is 1, here is nothing. Here is 2, here is 1. So I say what? Am I right? It's good. If I put n1, I'll get 2 to power 0 is equal to 1. If n is 2, it could be 2 minus 1 is 1. So I've got the reason. Or maybe the other student say, let n start from 0. Let b start from 0. Why not? Let be 0. So in that case, 2 will be n plus 1. Am I right? How about for here? I say just only n. How about for here? I can just write for n. Up to you. You can play with it. We say re-indexing. Do you remember that? Re-index. 4, 2, 3. We play with that one. So you can see you got the formula of that one. So, and it's a geometry, right? It's a geometry power series. Am I right? So that one, you can see that one is geometry power series. And R equal to what? X minus 2 over 2, right? That one will be your R. And find the value if you want. So you can see there's a relation between power series and Taylor series. So here's the first example. I'm going to briefly review it for you. First thing, you need to select f of x is equal to what and a equal to what. First thing. The second, find f of a, f prime of a, f double prime, I don't know. 3, 4, I don't know. 3, 4, up to you. Understood? Third thing is what? Substitute in the formula. Number 4, make a series, last series, n. And you get what you know what I mean. Okay. For applying these 4, I'm going to give you another example. This is just called a Taylor polynomial, no more else. What's the difference between this formula and the other one? It's just we have a finish, we have an endpoint. Look, find Maclaurin of f of x equal to x. Maclaurin we know. A is equal to what? 0. So how we do it? First formula, we say what? First thing, we need to select what's the phi f and what's the a. So the second, find f of 0 equal to what? F of x equal to e to power x. Okay. F of 0 equal to what? Hello? 1. Yalla. Derivative equal to what? Itself. F of derivative again 1. Second derivative, so second derivative, right? Easier. So by 2 terms, you got the idea. Now it's time to what? The third step. First step's finished. Second, now it's time to substitute in the formula. So how? I know f Maclaurin k at 0, x to power k, k factorial, k from 0. So I say I will get what? F of 0 itself, f prime of 0 it's x plus f double prime of 0, x square over 2 factorial, f x 3 factorial, and go on. So I'll get what? F of 0, f prime, 1 multiply x, f double prime, hello? F double prime equal to what? They? John? Yes, e to power x function. So all of function is equal to what? When we put the derivative over the value of 0, you get 1. So each of them, that one is equal to 1, that one 1, that one 1. All of them will be 1. So it remains what? X squared, x cubed, understood, and go on. أتوانم ما شلون برسم لمشكي خوما. Am I right? Am I right? زان راستكم. 0 factorial. Hello? 1. 1 factorial. Again 1. 2 factorial. 2 multiply 1 is equal to 2. 3 factorial. Here we are 6 and go on. So I changed that on 2 factorial. That on 2 factorial. Also that on 2 factorial. Why? Because the fourth is what? Understood. When n is 0, I'll get 1. When n is 1, I'll get x. When n is equal to 2, 3, 4. Was the power series, right? And we solved that one. It was converse. It was the third, I think the third example number 3. How we say for every x. You got it, Jamaat? Okay, very good. So now, kindly find that one with me. Another example. At 0. So Mac. Yalla. Tell me, and I'm going to write with you. Yes, a is equal to, so f of x equal to cosine of x, yeah? F of 0, cosine of 0, right? Yes. Yalla, first derivative minus, okay, so equal to what? Good. So I'll get what? Minus 1, good. What else, Jama'a? This city can. If you know how to solve that one later, you don't need to study actually. Just review. Okay. Do you get anything or we should continue? Do you get it? So you'll get what after that one? After one? right? So it's oscillated between 1, 0, minus 1, 0, 1. So good. يلا دعاء after. Formula, equation, okay. Equation, no, formula. So you have what? F of 0, F prime of 0, يلا tell me. So just I am going to substitute the function, okay? 1, 0, minus, okay, and right? So it remains what? 0, 0, we know. So 1 minus. Am I right? How about after that one? Hello? Yalla, important part. Plus x to power 4. 4 factor. Okay. After that one? Minus. Just write it. Don't forget about the 0. Now you. Now you know the formula, right? So it remains what? How we choose that one from n to where? You have all keys. There's no way. Yalla. One by one. Do not think about all of them. So first of all, I have alternative or not? Yalla, let me fix alternative one. So I have minus 1, yeah? So 2 power what? If I that one 0, 2 power what here? Right? If I change it, I will change it. Okay. So in numerator, Sarikert, yalla, we have what? Huh? X to power something, right? X to power what? N, yalla, let me think about n is good or not. N to power 0 will give me 1. N to power 1 will give me x, but I don't have x, right? 2n. Why 2n? We say, look at the power, it's going to what? Even. And we say even is what? 2n. Remember that. Good. That's why I say you have all keys. Good. How about denominator? I'm sure about that. I have what? I have factorial, right? That's going to what? 2n, right? So if n is 0, that one will be positive. That one will give me x to power 0, which is equal to 1. And that will give me 0 factorial, which also give me 1, right? 1 over 1, the first. The second, when n is equal to 1, that one will be negative. And that one will be x to power 2. And that one will be 2 factorial. So it's good. And go on. So you see everything is in its place, right? And there is no problem. You got it? Good. And look at the application. Look at the application. P0, P1, P2 to far, and like that. Minus x squared, right? You know, minus x squared. But we are going to talk about positive, that's why you have that. And minus x to power 4, minus x to power 6, like that. So this is one of the application. You can use it if you liked. So this is the formula of what? Formula of cosine, right? Mac of cosine. Okay. So can you solve as a homework right now? Can you solve f of x sine of x mac and tell me where's the formula? I think it's in your exercises. Yes. يلا.